Hello everyone. Today I will teach you chapter 2 differentiation. This is actually form 5 topic for form 4 students this year. This is actually new syllabus. Differentiation and integration will be under form 5. We call as calculus. So today I'm going to revise back the differentiation with all the form 5 students. So for differentiation actually is a very interesting topic, but some of you might think that this topic is a bit challenging to you. So it's okay, let's go through again, because I think last year you have learned but you've forgotten everything, right? So normally for differentiation, the first topic that you need to know is limits. Okay, so you must know limits, because from limits then we can actually derive the first derivative, which is dy dx. So limit is very important, and we have the first derivative, the second derivative, and application of the differentiation. So for form 4 student, I think you should have used the holiday to start to pick up the skills, because this topic is a bit tough, and I think next year you also will be burdened by the homework, so it's better for you to pick up now. Okay, normally for a function we will use fx, so we can also say this is y. So when we do the differentiation, we will say dy dx. Actually we are finding the first derivative. Alright, okay, so this is actually gradient of the tangent to the curve. Okay, gradient of tangent to the curve. The curve is always something to do with the curve. Okay, and then we have second derivative and application of differentiation. So this topic is quite long, so I think today I will just focus on the basic of the differentiation skills. Okay, now let's go through this form 5 textbook. Is actually very good because it comes with many information. It's a very creative textbook. So first thing, they actually introduce the bacteria. Bacteria can cause various dangerous sickness which can be life-threatening. Like nowadays we are having virus COVID, right? Bacteria produce toxins that can spoil food. Bacteria contaminated food can cause food poisoning when consumed by humans and can be fatal if not treated immediately. Among sickness caused by bacteria related to sickness are typhoid, fever, and pneumonia, to name a few. Do you know that the formula to calculate the number of bacteria growth, of bacteria P with initial population, is 1,500. So this is actually the formula for the population of the bacteria growth. So can you determine the growth rate of the bacteria population after 3 hours? Growth is rate, growth rate. Rate means differentiation. Alright, so this problem can be solved using differentiation, which is actually one of the field of calculus, because we also have integration. Alright, now so what is calculus? Calculus is derived from Latin, which means a paper used to calculate and solve mathematical problems in ancient times. Okay, so the two mathematicians' name who actually pioneer the study of basic principle of calculus are, we actually this one is the history of the calculus. You can actually scan the QR code here to find out more information. So the significance of this chapter. Okay, so for a moving LRT, the rate of change of displacement show the instantaneous velocity at the moment, while the rate of change of velocity shows the instantaneous of acceleration. Okay, so acceleration, velocity, we use differentiation. And then the concept of differentiation. can be used to determine the rate of blood flow in the arteries and at a particular time, and also can be used to determine the rate of tumor growth, all right, in the human body. So all these are the significant. Okay, for this topic actually we will focus on a few keywords. Example are limits, first derivative, gradient of tangent, second derivative, all right, equation of tangent, equation of normal, and turning point. Okay, all these are important keywords. Rate of change, approximation, stationary point, stationary, NARY, point of reflection. Okay, all these are keywords that you must know. All right, so okay, video on development of bacteria colonies, you can scan. All right, okay, you scan for a while, you can have the video show after this. Done. Okay, now limit and its relation to differentiation. Okay, for limit, I will actually create one video to discuss the limit, because limit is actually quite time consuming. So I will discuss the limit in another video. So today actually I want to focus on the basic skills of the differentiation. All right, so let's go through the basic principle for differentiation. Okay, find the dy dx using the first principle. This one is actually using the concept of limit to find dy dx. All right, so this one you go through on your own. Okay, so this is using the first principle, find the first derivative. Okay, or first derivative also means dy dx. So today I will go very fast to do revision with all the Form 5 students, especially about the differentiation. So we have this formula, right, that you learn in Form 4, all the Form 5 students. So this video is just to introduce differentiation to Form 4 student, and at the same time I would like to do revision with the Form 5 student. Okay, because they are going to sit for SPM. So today I would like to do revision with all the Form 5 students out there, okay, to prepare for the SPM exam. So I will be using the Form 5 KSSM textbook, because the textbook is very good and is actually very creative and a more hot question. Okay, so let's go through the differentiation with me. I will do a few video, try to update as I free for differentiation, which many of you are quite scared of this topic, right? It's a bit challenging, huh? Okay, actually not really. This topic is quite easy. It's just that you need to practice, keep on practice. So derivative formula. Okay, we start with the derivative formula. So whenever you want to do derivative, you must make sure you have the, we call as a power form. Okay, this is so-called power form. Why I call it power form? Because from the term I can see the n, right? There is a power. So it's very important you express in power form so that you can use a formula, because the formula is like this. You see, the formula is like this. You just express in power form. The AXN, right? N is a power. Okay, so I just want to highlight you the N. It's actually power. So I call this as power formula. So how you differentiate, how you find the first derivative? Derivative means dy dx. You just bring the power down, okay, to in front, and the power minus by 1. Alright, so this is actually the most basic formula whenever we do differentiation. The very, very basic formula. Alright, so the three notation used to indicate the first derivative. Okay, we have three ways. First derivative means you can write dy dx, you can write as d dx like this, meaning that they can say dy dx, they can say differentiate d dx, okay, differentiate, or they can say find the first derivative. So there are three notation used to indicate the first derivative of a function y equal to axn. So let's see how to use a formula. Now you see this one, okay, you have 2, right? So the 2 bring to in front, 2 times 3, then x2 minus 1, right? So it becomes 6x1, so we write as 6x. Alright, okay, so dy dx is actually read as differentiating y with respect to x. Okay, when you do dy dx, you don't read dy per dx, no. You don't say dy by dx, no. Differentiate y with respect to x. Okay, you need to respect the x. X is very important because dy dx depends on the x value, so we have to respect x. Okay, right. Okay, so if you differentiate like this, you write dy dx, right? So in other words, in other symbol, we can write y as fx. So now if I ask you to find f prime x, it's the same that I ask you to find dy dx. Same story. Okay, so the f prime x is known as gradient function. Okay, gradient function. The moment you see gradient function, it means f prime x. It also means dy dx. Okay, same story. Alright, so it doesn't mean y, it means dy dx when you see gradient function. Okay, understand? When you see function, you say y, okay, no problem. But when you see gradient function, you cannot say it's y, right? You must say dy dx. Okay, understand? Okay, gradient. Okay, for the curve y equal to fx, because the function can be used to find the gradient. Okay, it's not a function because this function, it can be used to find the gradient, so we don't say it's function, we say gradient function. Okay, dy dx means gradient function. Very important keywords. Whenever you see gradient function, you quickly write dy dx. Alright, okay, so dy dx depends on x value. Alright, so you know you have to learn how to write dy dx. There are 3 ways. Another way is you do like that, you write d dx. Alright, you can write like this. It also means that you differentiate the y. This is a y. Alright, and the y is, what is the y? The y is 3x squared. The y is 3x squared. So that means instead of write like this, we will substitute the y 3x squared. So that is how we write the shape like this, 6x. Okay, understand? So differentiate 3x squared, you get 6x. If differentiating 3x squared with respect to x, the result is 6x. Differentiating. Okay, that's how you represent the dy dx. There are 3 ways. One is y equal to 3x squared, you find dy dx. Or you can say if fx equal to 3x squared, you find f prime x. Or you can write as d dx 3x squared equal to 6x. The same story. Alright, so today we want to discuss a few questions on dy dx. Okay, we have many formula. So when you plus or minus, it will follow for dy dx for the function. Okay, like this example, you differentiate the 5x cubed plus 3 over 4x4. So that means you can differentiate term by term and there is a plus. Okay, so you must plus. And finally, you will get the answer simplified to the 15x squared plus 3x3. Have to simplify, okay? Simplify to the simplest form. For this one, okay, you see before you can differentiate, you must see the power with the constant. So you multiply, so it's x1 times x half, right? So that means you have to distribute, you have to expand like this. Power 1. Then only you can use the formula, okay? Bring down the power, okay, power minus 1. Okay, bring down the power, power minus 1. Okay, when you differentiate a number with x, you always get back the number. Alright, and then when you see power half is actually square root. So this is how you differentiate. Okay, differentiate each term separately. one by one separately. If minus minus, if plus plus. Okay, like this example. Okay, when you differentiate, alright, you have to expand first one by one. Expand. Okay, then you simplify with this. Then you cannot differentiate yet because you still haven't see the power form. You must see the power of the x. Okay, so now you have to simplify constant. Okay, then x 1 over x, this is from 1 over x. That means you divide term by term, you know. You must do like that. Is equal to 2x squared over x minus x over x minus 1 over x. Then you cut 2x, then minus 1. Then this one bring up, you must see the power, right? Then only you differentiate term by term like this. Okay, you differentiate 2x, you get 2, right? Different one, you differentiate any constant, you get 0. Okay, so normally we see constant, we just ignore, we write 0. Or if you don't want to write 0, it's okay. This one be very careful, negative and negative become positive. Alright, then after you differentiate, you get 2 plus 1 over x squared. Always converting back to the positive power. Bring down to the denominator. Remember a, the indices log a negative n equal to 1 over a n, right? Okay, because easier for you to substitute the x value after this. Okay, so today I just want to discuss important concept and skills of differentiation. For chain rule, okay, this one I will discuss also in the exercise later. Then for chain rule, we always have the two function, right, multiply by each other. Okay, so let's see how. So example, you have the this one, differentiate each of them with respect to x. This is a chain rule. So how you do is actually like this. You want to find dy dx, right? So you take the power down. It's just like just now. This whole thing, you copy the rectangle. Okay, you copy down the rectangle. Don't do anything, just copy this rectangle. Okay, this rectangle copy, and then you take the power minus 1. You know the power minus 1? This one 7 minus 1. And then you have to differentiate whatever inside the rectangle. Okay, which is like this. Okay, that's how I ask my student to do so that they won't forget. So you do like this. dy dx is equal to 7 3x squared minus 4x, so it becomes 6, right? Then you differentiate. Okay, 2 times 3 6x minus 4. Okay, that's how you do. So you don't forget this last step. Okay, so you see this is how you do. You can use a chain rule actually. 7, then this thing 6x minus 4. Finally, you can simplify this 7, you times to this side, but don't times with the power 6. Power 6, higher power, don't do anything. Okay, 7 times 6, 42x minus 28. So your dy dx, you can leave in simplest form like this. Okay, or you can use u and u. Okay, u to substitute the 6x squared plus 8. Then your y equals square root u. Then you do du dx and you do dy du. Alright, then you get dy du. You bring the power to in front. Okay, then the power minus 1, right? So you get this. And then you use a chain rule. Alright. Okay, then you get the answer. So I'll go very fast. So normally I will do like this. I don't actually use a u unless the question force me to do. So I will actually do one step like just now. Okay, now let's discuss how to do question like this. Example, we discussed a few. Example for A, I want to differentiate this, right? So how I differentiate this, I will take the 5, I will copy x plus 4 and then 5 minus 1, and I will differentiate the x plus 4. Okay, so I will get the answer, which is equal to 5x plus 4 to the power of 4, and then differentiate x is 1, differentiate 4 is 0. So my answer is 5x plus 4 to the power of 4. That's it. Okay, understand? So that is so-called chain rule. All right, so let's say, all right, let's discuss another one. I would like to discuss f. This one looks a bit challenging. Okay, let me show you how to do. You can always assign like this: y equal 2 over 3 5 minus 2x to the power of 9, right? And you say, okay, dy dx is equal to 9, you bring to in front, times 2 over 3, you copy everything, right? And then you take the power minus 1. Okay, don't forget the power minus 1. This is the step that student always forget. Differentiate this thing always. Student just differentiate inside the bracket without the power 9. All right, so now your answer is, you just simplify 3 1 3 3 6, then 5 minus 2x to the power of 8. Then you differentiate 5, get 0, differentiate negative 2x, you get negative 2, right? So then you just simplify the number and this thing remain as power 8. That's all. Okay, understand? Okay, you want me to discuss one more, or you understand it? Okay, so I think you should be able to do on your own. Okay, I leave it for you. If you're free, you can try to do this one. One day you do a few so that you will recall the skills. All right, maybe do this one and this one. Okay, right? 4 questions. Okay, now we discuss another one. Differentiating each of the following expression with respect to x. Okay, how about this one and this one? How to do with the square root with the power negative? Okay, let me discuss one with you. I do A. Okay, for A, let's say I have okay, you can write like this: fx equal to 3x plus 2 to the power of negative 1, right? You bring up. Okay, so now you can write, you learn how to differentiate using f prime. Negative 1, copy everything, right? Then minus 1 minus 1 minus 2, and don't forget differentiate inside the bracket. So this is your answer. Very easy, right? Negative 3, you can write in fraction 3x plus 2 to the power of positive 2. Alright, clear? This is 2. Let me write properly. Okay, now I do another one. Let's say I do B. For B, I do B for you. So you keep on practice because your holiday quite long, right? So if you didn't do, I'm afraid that you forgot when come to SPM exam, right? So now you just keep on practice like playing game. Alright, so now I bring up the power, become negative 3, right? Then g prime x, you know, negative 3, then 2x minus 7, then minus 1 will be minus 4, and then don't forget differentiate inside the bracket. So negative 6, 2x minus 7 to the power of negative 4. Then you can write as negative 6, 2x minus 7 to the power of 4. Alright, settle? So I think I do one about the square root one for you. Alright, let me see. How about this one? Choose this one to do. Okay, let's say this is my y. I will write x squared minus x plus 1, and I will write power half for square root. Okay, I do here dy dx is equal to 1 over 2 x squared. I copy everything. It's easy, right? Copy. Minus 1, 1 over 2 minus 1. You can press your calculator, and then I will differentiate inside the bracket 2x minus 1, right? Okay, so now I just simplify my answer. It will become, okay, 1 over 2. When I see x squared minus x plus 1, there's a negative half here, 2x minus 1. So okay, I can't do much more. I can only convert the square root into symbol, square root like this. Alright, this one setter bring down, it become positive half with a square root. Then the 2 still down there, then the 2x minus 1 up there. That's all. This is the answer for the chain rule. Okay, setter? So the rest maybe you can try on your own. This one is after you differentiate, you substitute 1 inside. Okay, you can try. Alright, so then this one you can try. Okay, clear? Chain rule. Today we'll discuss the chain rule. Okay, so maybe I try to go through with you all the rule so that you won't forget. We have the product rule. Okay, in general, the formula to find the first derivative of the function involving the product of two algebraic. So you multiply the two algebraic. Alright, so then we have to use the, when you multiply we say product. Okay, we use this formula. Okay, I'm going to show you how to use a product rule. Example, you have the function like this: y equal to x minus 1, x minus 4 to the power of 3. Let's say. So this is actually algebraic. This is also algebraic. Two function multiply, right? So what you need to do is actually you just follow dy dx. Okay, you actually just copy down everything like this with a plus. When the product is always plus. Okay, example, you have logarithm, two number multiply, right? Okay, so you also plus, isn't it? Right. Okay, so now I want to show you how to recall the formula for the product rule. Okay, so like this. I'm going to tell you what I will do so that I won't forget every time when come to product rule. So I will do like that. I will copy down everything. Then I will remember what my teacher teach you. My teacher say whenever you got product rule, you have to do like this. Is always you copy this thing. I'm going to highlight to you. You copy this thing. This one you differentiate. Okay, it's u dv dx. If I give you the formula, you can't recall, right? So that's how I do. Then after that, because you have to rotate. Just now you differentiate this one, the second one. Now you have to differentiate this one. And this one you don't differentiate. So this one you do. This one you don't do. This one you do. This one you don't do. Okay? Alright. Understand? Again, I highlight to you the way to remember. Okay, it's like that. This one you differentiate. So D plus, okay, then this one you differentiate. These two no need. X ddx. Can remember? This is the shortcut. X means don't do. Okay, x ddx. Understand? Okay. But some teacher they teach you O plus DO. OD DO. Okay? So meaning 0 means you don't do. This one you do. Do means differentiate lah. D means differentiate. Differentiate. So don't differentiate, differentiate. Then differentiate, don't differentiate. Rotation, rotation. Okay, can memorize the shortcut that I teach you? Okay, let's do one question so that you can recall. Let's say this one. You have two functions, right? You have two functions. Now, I'm going to show you how to use a formula. This is actually your U. This is your V. Okay? So, but I'm not going to memorize the formula. The formula is what? dy dx equal to u dv dx plus v du dx, right? It's a formula. So what I need you to do is you just make it the multiplication. If not, you have to use a quotient rule. So I want you to do it. X you bring up, it become negative, so it become u times v, so that you can use this formula. Because we have another formula which is quotient, so it's better try not to use quotient because it's very complicated. So I make it multiply so that I can use a formula that I teach you. Okay, now as I say, you have y equal to x minus 1, negative 2, right? So it's multiply, right? It's multiply. Can you see there is a multiply? Okay, I show you the multiply is here because it's here. So normally you use a dot lah, because it multiply means it looks like x, very confusing, so we use dot. Okay, now I'm going to teach you how to do. See, I use the way which is very easy to remember. So y you copy down, give some space. Okay, plus is our multiply is always plus. Here give some space. Alright, here x, here x minus, copy. Why you copy? Because so that you memorize the steps. Okay, after you copy, do like that. You're going to differentiate this thing. The one that you need to differentiate, I use a purple color. This thing. This one, you have to differentiate. Okay, this one you don't do. This one you don't differentiate. This one you don't. So d plus d, okay, od do. Okay, memorize. Alright, so now I'm going to differentiate. See, I'm going to show you how I differentiate. So dy dx equal to, okay, this one don't do, right? Don't do. Negative 2, copy. X minus 1, copy. Minus 2 minus 1 minus 3. Then differentiate this thing. 1. Differentiate x. Plus, okay, x differentiate is 1. Then this thing just copy. Alright? Okay, now you need to simplify. Okay, how to simplify this one? The problem is you want to take out the common factor. So now some people will have problem to factorize. So this one I want you to write this negative 3, right? You put the base as x minus 1, negative 2, negative 1, because I want to see the common factor, which is these two. Alright, you can see or not? Is it very confusing? I write properly. So now my dy dx is negative 2 x minus 1. I make it negative 2, then x minus 1 plus x minus 1 negative 2. Why I do that? Because I want to focus to the common factor. Now I highlight to you. Where's my common factor? This one. Make it thicker. Okay, and this one. These two can be taken out. Okay, because they are common. Common means they are same. Alright, understand? Now, okay. Oh my god. Okay, now you see, I'm going to show you how I factorize dy dx. So I'm going to take out x minus 1 to the power negative 2. Then the balance will put inside the bracket. What are the balance? The balance are negative 2 x minus 1 plus 1. Okay, this thing is 1. How to get 1? You just take this one dy. This one dy. Alright, you get 1. Okay, settle. Now your answer is, if you want to write the simplest answer, it should be this one go down, x minus 1 square, and this is negative 2x plus 2 plus 3, right? Okay, so finally your answer you can write like this, dy dx equal to 3 minus 2x over x minus 1 to the power of 2. Alright, this is the answer using product rule. Okay, so I have shown you how to differentiate this one using product rule, right? Okay, so you have to use the product rule. If not, you have to use the quotient rule. We have another rule which is quotient rule, like this. Okay, so for quotient rule, you see, it's a bit complicated. because it's involving dy. So we come first. We. Okay. Always take care of ourselves. We come first. We du dx minus u du dx over v squared. Okay, this formula many students cannot memorize. That's why they cannot do. So now I'm going to teach you how to memorize this formula. You see, for this one we use product rule because it's multiply. Okay, so you want me to show you how to use the product rule? Okay, I show you for this one. This is very complicated. I show you before I use the quotient rule. I show you this one. Okay, so I say dy dx is equal to, okay, before that we copy down first, right? So 3x plus 2 d dx square root 4x minus 1, wow, got square root, plus, and then this one we differentiate this 3x plus 2, and then we copy down this one, don't do. Alright, okay, od do. Okay, so now we copy down 3x plus 2. Okay, how to differentiate this? I need to have the power half. Okay, so I show you. 4x minus 1 square root, right, is power half. So you bring the power down. 4x minus 1 minus 1 over 2 minus 1 is minus half, then times 4. Got it? Cut will be 2. So it's 2 4x minus 1 negative half. Alright? Okay, I show you here. So it's 1 over 2, and then I will write 4x minus 1 negative half, and then I times 4, right? And then I differentiate this one, I got 3, and this thing I just copy. Can you understand? So now I can actually, I can't do much. I can only simplify the 2 and the 4 become 2. So it becomes 2 3x plus 2, right? And then this thing will go down, square root 4x minus 1, and then plus, make it longer, 3 square root 4x minus 1. Okay, finally, my answer will be, I made the denominator the same by multiply with this thing, 4x minus 1, 4x minus 1. So I will get, okay, now I can join them, for square root 4x minus 1, and I will get 6x plus 4 plus 3. This thing, the square root gone, right? Okay, let's simplify further. So wow, it's so long. Plus 12x minus 3 over square root of 4x minus 1. Finally, we have the 18x plus 1 over square root of 4x minus 1. This is the answer after we use the product rule for B. Okay, it's very complicated. Right, see the answer here is very complicated. 18x plus 1. Alright, it's 18x plus 1. Okay, over square root 4x minus 1. Right, same answer. Who is this one? V du dx and u du dx over v square. Okay, so I will continue next video teaching lesson. Alright, bye bye and have a nice day.